Hey everyone! In the first part of this video, we'll create a character's face from different angles in ComfyUI and add some emotions to it. In the second part of the tutorial, we'll train a LoRA to capture these facial features, so we can later use the character's appearance in various styles, costumes, eras, and locations. So, if you're only interested in training a LoRA based on the FLUX model for a specific appearance, you can skip ahead about 5 minutes and continue watching from there. Let's get started. Using this workflow, we'll create a character's face from different angles, set up a few emotions, and generate 10 images, which will be enough for LoRA training. You can download the workflow from my Patreon via the link in the description. It consists of several stages. The first stage is creating a base image of the same face from different angles. That's why I place all the images on a single sheet, so the program understands it's the same person and strives for consistency in appearance. The second stage is enhancing facial features using the Face Detailer extension. Next, upscaling. Then, cropping into equal-sized images. And finally, adding a few emotions. This is the node for enabling and disabling blocks. It's best to disable all blocks, except the first one, and move to the next stage only after you're fully satisfied with the previous one's results. This node lists all the models you need to download and which folder to add them to. Let me briefly explain each block. In this group, I use LoRA and ControlNet. LoRA, Diffusion Model Loader, Dual Clip Model Loader, VAE Loader, Image Width and Height. Positive Prompt, where we specify generating multiple angles with head rotations at different angles. Empty Negative Prompt Node. Next is a group of nodes standard for a custom sampler. Seed, Sampler Name, Days and Scheduler, Beta, OpenPose Map. Apply ControlNet. These values worked well for me. This receives the positive and negative prompts, ControlNet Model, VAE, and the OpenPose Map image. ControlNet Model. I'm using a model from InstantX. Apply ControlNet passes data to Flux Guidance, which goes to Basic Guider, and then to the sampler. So we've got a draft image. Activate this group and move on. Here, I need to pass parameters like the model, positive and negative prompts, clip, and VAE. To avoid dragging long lines from the first block, I'll use a bus node. Here's where I call it. I pass all the necessary parameters into it. I set a variable, which I name bus. In the second block, I call this variable. And again, I add a bus node and pass all the necessary values to the toDetailer pipe node. Face Enhancement Model, optional node for specifying the face area size. In this node, we write a prompt if we want to emphasize specific facial details, like expressive glowing eyes or a small mole on the cheek. Face Detailer with customizable parameters. I also assign a variable to the image after facial feature enhancement. Let's check. The face details have improved. Enable the next group of nodes. Here, I'll also use a bus node to pass parameters. I like the results this model gives for upscaling. Let's check the result. The face looks sharper. Now we need to split this image into 6 equal parts. Enable and move on. Here, I call the variable from after upscaling. In this node, I manually input the width and height, which you can check in the previous block under the image. Here, I specify the image width and height, adjusting them through trial and error. In the end, the suitable size turned out to be 760 by 760. I also adjust the X and Y axis offsets. The same goes for all the other portraits. Here's the entry point for adding a file name to each saved portrait. This is set at the beginning with a variable. Now all files for this character will be saved in the output folder with the assigned name. So, we have the split portraits, and now we can add a few emotions for completeness. Enable this block. Here, we'll use the Expression Editor, PHM node. It allows you to adjust various facial expressions: head tilt, winking, smiling, sternness, open or smirking mouth. Different combinations create different expressions. For example, the wink parameter controls winking. Here, it's head tilt and smile. You need to experiment. Pay attention to the crop InSynap parameter. By default, it might be empty, and the node will turn red, signaling an error. So, you must set a value here, with a minimum of 1.5 up to 3. So, we have everything we need to train a LoRA on the character's facial features. You can run the portraits through another upscale, but I think this resolution is sufficient. Save them to a folder. For LoRA training, I'll use the FluxGym tool, which I'll launch via the Pinocchio service. This service lets you run multiple neural networks in a single environment and automatically installs all the necessary software. Here's an important note. The old Pinocchio website, where you could download the installer, is no longer active. Developers don't support it anymore. So, we'll download from their GitHub page. It's crucial to install the latest version, as older versions link to the old site and won't work. So, let's head to the developers page. Here, open the Releases tab. And for Windows, download this version. Unpack and install it. Open the Pinocchio program. Go in Discover. In the search bar, type FluxGym. Click, one-click, Install. Install. Wait for all the necessary software to install. Download. Wait. Install. Wait for FluxGym itself to install. Once the installation is complete, the Gradio interface will open in Pinocchio, but I want to run it in a browser. I go to the terminal and click the link. So, the LoRA training environment has opened in the browser. In this field, enter the LoRA name. In the next field, enter a unique trigger word. Then, select the FluxDev model and your graphics card. Leave everything here as is. To visually track the training progress, enter a few prompts in this field. My character is sitting in a vintage chair, holding a glass of wine, and riding a horse. The D123 parameter is the seed. Here, we set how often intermediate images will be displayed. Next, upload the face images from different angles. If we click this button, automatic prompts will be generated. You must check them, as there can be inaccuracies. For example, one field says long hair, while another says short hair for the same hairstyle. Once everything is corrected, click the Start Training button. A message appears saying the FluxDev model will be loaded, and it suggests going to the console to monitor the process. The model is downloading. Other necessary models like Clip, VAE, etc. are also being downloaded. Then, switch to the browser, as everything else is displayed there. The first intermediate frames appear, and they look nothing like the reference. That's normal. As training progresses through epochs, the similarity will improve. In the next set of images, some similarity starts to emerge. But what's shown here isn't indicative of the final LoRA. Here, all the intermediate images are displayed, and the similarity is still minimal. I'm showing you this chaos so you're not confused by what's generated during training. The final LoRA will be fine, and you'll see that soon. A message appears that training is complete, and the LoRA is ready. Go to the FluxGym folder. Your LoRAs are in the Output folder. Move them to the ComfyUI Models LoRAs folder. Now, let's run a basic workflow and test our LoRAs. You can see how well the LoRA captures facial features. For maximum similarity, the value here should be 1. In the prompt, you need to include the trigger word you set during the training setup. If you forgot it, you can find it in the FluxGym folder, Dataset, under the Model's Name folder. You can also check the prompt text there. You can combine your LoRA with other LoRAs downloaded from Civit AI to create unique styles. If you enjoyed this video, give it a like and subscribe to the channel.